Okay. The name of the presentation is Intelligent Transport System and Smart Traffic Management. And me and my colleague, Dinu Covaciu, made that presentation. It's focused on ITS concepts and the traffic simulation softwares, and also a short example of ITS system and ITS strategy from my city, Brașov, from Romania. We start with the problems. The problems we have in our city, I think is the most common problems also in the city in whole Europe, especially in Romania. The impact of the large number of the vehicles in the traffic flows. The problem are mostly in urban areas, so the congestions, the jams, especially in rush hours, are the biggest problems. Also the impact on pollution for the environment and the cities and the inhabitants. That needs to make specific solution and try to resolve these problems. So ITS components and ITS systems can be one of the tools that we have to resolve these problems. So the main ITS intelligent transport system concepts are computer technologies, the platforms and tools used to solve the problems in transport system, floating car data, the data from each vehicle connected to the grid and the system, and detection technologies, the sensor, and all about the infrastructure of the system. And the primary objectives of ITS knowledge are efficient and comfortable transport, safe and secure transport, and also cleaner transport in noise pollution and also air pollution, and everything reduced to CO2 when we talk the calculus from the most important documents that we have in order to resolve these problems. So these ITS components in sustainable urban and rural strategies have specific needs depending on the type of the city. It's a small city, it's a medium city, it's a large city, it's a metropola. In order to make the right choices in implementation of ITS components, we are needed studies. Traffic studies, impact studies, necessity studies, opportunity studies, sustainable urban mobility plans, and for each of one of these kind of studies, we need specific tools. And one of the tools is the transport model. The transport model will help in these studies to evaluate the traffic flow, to calculate the flows on specific routes and areas, and also prediction for the future, in order to select the most efficient solution and the most appropriate plan. So for simulation software tools, we have three types of traffic simulation models: microscopic, macroscopic, and mesoscopic modeling. Each of one have different types of tools and ways to make the evaluation and the simulation happen. We have a big diversity of softwares. I present two of them. They are the softwares that we use in our studies. The first one, it's named Synchro Plus and Sim Traffic. I will explain. Have two components. One for the design the traffic network, and the other one we needed to obtain the result and make the simulations. And the second one is vSim vSum from PTV. It's a tool that is most common used for SUMPs, and it's much complex than Synchro or Sim Traffic, but I will make the observation of the difference between them. So Synchro have an network modeling part when we build the structure of the roads. We make the links, the junctions, the signals, the lanes for each road, the traffic flows, the data from the traffic flows, the signals that can be changed in order to optimize the junctions, and also we make the traffic analysis. For the traffic animation, Sim Traffic component, it's an animation tool that shows the traffic jams, also fast, slow, and stop animation in each time to see what are the problems from the infrastructure and the mobility of the flows. And 3D viewer convert the two-dimensional network to an 3D view. So for the network modeling, the objectives are coordinates junctions, independent junctions. Also, you can analyze only one junction, or we can analyze an entire route. We can make choices for traffic signs or traffic networks, and also we can analyze different types of junctions. For the roundabouts, it's one specific problem. For the traffic data, we can enter the vehicles that go forward, that turn to right and turn to left. But for the roundabouts, we can introduce the turning at 180 degrees on the same road. So the movement go to the left. So this is the problem with Synchro and the roundabouts. In order to prepare the network model, it's mostly very simple. We can draw network using the mouse, link the distances, and connect the junctions. Specify the junction geometry, number of lanes, distances, and how the road go, and the number of entrances. Also, we can enter the data for the traffic flows. We can specify the signal control. We can also make the signal timings, and it's very important for the simulation. We can see the animation and see if something is not right. And we can analyze the model, the links, the junctions, and report also the type of the access, and also the fuel consumption and emission estimated for this intersection. So in order to enter the data, it's a quite simple module. The interface is very friendly, and you can enter the data and see how you have this chart on the right, that the data input for one intersection you can see it and you can modify if something it's wrong in the input um, part. Afterwards, we have the results, and this is a sample result when we have the level of the service for the intersection, also the time losses for each lane and for each entrance in intersection, also fuel consumption and several pollutants estimation. Level of service is very important, but not only the specific parameter that we analyze. Also, the intersection delay, the number of stops for each vehicles, especially for the roundabouts, and the impact on the environment. The 3D viewer convert the two-dimensional models from sim traffic to 3D viewer application. And you can see movies about how the vehicle enter and exit the intersection, where are the problems, where are the time losses, and where are the congestions. The second one is vSIM. It's a tool, it's very popular, mostly in Europe. The difference between SIM traffic and vSIM is the complexity of the data that you can enter in this software, and also the type of the analysis. But also, and the price of acquisition this software is much bigger than Synchro. So we have licenses for students only from 1 year ago. So we are starting to use this tool also. And the presentation is from the tutorial, because we not quite use it on our studies, because what you see in Synchro, there are results from studies that we have in last 10 years. For PTV, we have junction layout comparison, roundabout versus signal control or multimodal services, transport development planning, capacity analysis, active traffic management. It's a very important tool for this software. Public transport simulation, multimodal interchanges, and pedestrian movements. We can't make the pedestrian movements and data in Synchro, but in PTV-SIM, we can do this part. So the graphical interface is more complex than SIM traffic. You can use it very friendly. You have to study the documents. You have to have training lessons, because it's much complex, and it's not very friendly, just like SIM traffic. So the network objects are in the sidebar in number 1, network editors in panel 2 and 3, quick view in panel 4 for the data that you input, and lists, view and edit base data of graphical and non-graphical network objects on panel number 5. So with vSIM, we can make network modeling, import base map. We can use map from Google Maps or from any kind of GIS tool, Google Earth, or everything we can use. We can create links to several lanes from the GIS tools, and create connection between links. The vehicle inputs, we can enter the traffic volumes, the vehicle routes, vehicle speed, and we can run a simulation and define also the vehicle types. The types of the vehicles are much complex than Synchro. but you have to be very careful when we collect the data. But also vSIM have a new tool, then can use the online and open source traffic flow data. So PTV and vSIM can use data from Google Maps, from examples, number of the vehicles on one route and in one specific interval. So it's no longer needed the collection of the data. Also, they have the pedestrian movement simulation. Viswalk, it's this specific tool when you can see the pedestrians in 2D and 3D also, and how they enter and exit from an transport vehicle. And also the model and simulation for a complex intersection, it's very good quality. It's a lot of data that you can enter, but I repeat, it's not very friendly to use. You need a lot of time to learn and also to use correctly this tool. These tools are used also from the local authorities. We collaborate with the Brașov City Hall. I am a specific consultant for City Hall in this matter. So I present last strategy example, an ITS strategy. It's a project, centralized traffic monitoring and control system for municipality of Brașov. The specific activities of the project, it's a road traffic management system implementation and use the all technical subsystems in the one specific network. Creation of a traffic monitoring and control center. It's a very big step forward to have a central brain, so I say, for all the city and for all ITS components. Optimizing the use of the parking lots because they are in most of the roads are in conflict with public transportation lanes, and reducing the pollution and CO by encourage the travel with public transport. And this the strategy is to replace the big number of the personal vehicles. So the traffic monitoring and control center will be established somewhere in the central part of the city, and the command and control center will use also tools like auto plate recognitions and also all kind of video surveillance systems that can control all the problems and all the traffic network in the city. An objective is the public transport prioritization and traffic management system. They want to use equipment for prioritizing public transport, for video surveillance, also big communication network related to the system, and this is the most problems that appear, and also complete the infrastructure that they already have it. And the last component, it's a parking management in area of public transport lanes because the bus lane, it's next to the parking on the road. So they have a lot of conflicts, and they try to optimize the mobility and the parking strategy. These tools are integrated, and now they try different scenarios. So they use also the PTV vSIM vSUM simulation to make the right choices for these ITS components. Thank you very much. That was my presentation.
Yes, Stelian, thank you very much. You hear us? Yes.
Yes.
And while my colleague preparing for questions, may I ask you also, when we can ask now? Yes, we can start the discussion after each presentation. So who is online, you can write your question to the chat or switch on microphone and ask. Let me ask you a question. You compare to software, PTV, vSIM, and I'm not.
Synchro. Synchro or SYN traffic.
I don't know it, but I see the same approach, a lot of same parameters that you can calculate. The question regarding ecological parameters, because as I know, in PTV vSIM it's possible, you can change model and calculate the difference regarding, and you show also in your presentation this moment, you can calculate ecological factors. What about frost? Can you receive this and estimate these parameters also?
Yes, the difference is in SIM, in Synchro, you can not use the data for the pedestrians that we can use in vSIM, vSUM, but it's very complicated to have data on pedestrians. So in vSIM, vSUM, I don't know, there are not a lot of the users that use the pedestrian part. Also, the roundabout, I talk about it, have a problem in Synchro because you can not enter the turning at 180 degrees on a road. So you put it on the left turn. So that's the problem with the roundabouts. And also the complexity of the type of the vehicles. It's personal vehicles, public transport in one or each categories, but it's fewer than in vSIM, vSUM.
So you can calculate in both, but in first software you can calculate it only for traffic.
Yes, and then you can make a transport model. We use it for SUMPs. We also made SUMPs, and in the third presentation that I also will make it, you see, we present SUMPs results, and we use Synchro for transport model. And it's enough for small and medium cities, but for metropolis with a lot of components, vSIM, vSUM is most appropriate.
Okay, thank you. Any other questions? Antonio, what do you think? How organize the question? Because from yes, come here or
it's possible.
Let's start maybe Victor start and you say, do you hear him or not? Okay, because
yes,
okay, good.
Hello, Stelian, do you hear me?
Yes, I hear you.
Thank you. Thank you very much for your very interesting lectures, excellent lectures on intelligent transport systems. There is critical area for modernization or restoration through modernization in transport infrastructure in Ukraine, especially post-war time.
Yes.
We are interested in your opinion, your vision on practice issues. First, integration all systems, traffic system, for example, these new technologies in the Ukrainian conditions. And second, how to solve problems integrating different traffic data resource based on the different technologies. For example, Galileo GPS technologies, GIS systems, MANET technologies based on floor, car data, and traffic sensors. Thank you.
Okay, the first of one, for each type of city, mostly the big differences from cities also in Romania, from each city, but especially between the countries. So the first one is the existing infrastructure. If you have a good infrastructure for transport and also a good connection to the internet, you can use tools that they work very fast and they have instant results. But if you have problems with connecting the internet and also problems because you specified the afterward reconstruction for some cities, in Romania, we have very good quality of the internet signal and also GPS coverage. But if you don't have the infrastructure very good for GPS and for all the tools that need internet and GPS, it's very difficult because you go with new technologies, but afterwards you see they don't work properly. So you have to, for the start, to have the infrastructure, and afterwards you have to select the specific tool, and this is regarding also how much it costs. How you can implement it, how fast, because if you take 2-3 years to implement a system, in 3 years, I think it's obsolete. So you start from the infrastructure, your budget, and your first needs of the population. The need to travel fast, the need to have more accessibility, or the need to resolve the problem of conjunctions and junctions. And each city is different, and each city have an SUMP, and each big city has an SUMP. And based on the problems, we make the solution and also the tools for the solution.
Okay, thank you very much. Thank you.